All right, so what we just talked about was that rhombuses are made of 4 congruent sides. It's a parallelogram with 4 congruent sides. So that means if one of the sides is 27, all of the sides are 27. Like that. So XY is 27. WP, which is this piece, has to be what? What do you think? In a rhombus, diagonals bisect each other, just like any parallelogram, so that has to be 21 also. And then we have PZ, which is kind of confusing because here's PZ over here, and we don't have any way to indicate its measurement. There's nothing here, and that's it. But in a rhombus, diagonals are perpendicular, and that creates 4 right triangles. There's one right there. So we have, I'm going to redraw it up here so you can kind of see what we're dealing with over here. We basically have this right now, a right triangle. This side is 21, this side is 27, and we want to know that side. Does anything jump out at you? We have 2 sides, we're looking for the third, so we need to use the Pythagorean theorem. All right, so we're going to put them in. Which one is C? Is it 21x or 27? Hopefully you said 27. So 21 squared plus x squared equals 27 squared. So 441 plus x squared equals, I'm going to subtract 441. So x squared equals 288. We can simplify this, or first we have to actually take the radical. I just forgot that step. So the decimal equivalent, just the square root of 288, is approximately 17 when I round it. Or you could do simplified radical form. And I recognize 144 as the perfect square of 12. So 12 root 2. All 3 of these answers are okay. I'm going to go with 17 though. So PZ is 17. And I just slid that over way fast. So if you need to go back and pause it to write it down or have it sink in, go ahead. All right, and that is all of the sides. Now let's look at the angles. Angle XZW. XZW is right here. In a rhombus, diagonals bisect opposite angles. So, or bisect the angles. So if this is 51, sorry, then that's 51. So they're both 51 degrees. Angle XWZ is this whole thing here. We don't have any alternate interior angles to use or any bisected stuff, so we're going to have to look and see if maybe the consecutive angle deal might work. So I'm going to kind of look at it like that, a little hug underneath there. This angle here is 102 degrees together, and consecutive angles are supplementary. So we're going to do 180 minus 102, which is 78 degrees. So that whole angle here, I can't fit it inside, is 78 degrees. And the last thing we need to figure out is angle ZYW. ZYW, this one. Well, because of what we just did over here, we know that this whole angle here is 78 degrees. And in a rhombus, diagonals bisect the angles. So 78 divided by 2, I think it's 39. Yep, 39 degrees. All right, again, this is the craziest versions of these. We're going to go over some simpler ones in a few minutes, but first, squares. A square is just a combination of a rectangle and a rhombus. So it combines the properties that go with those. In a square, it has 4 congruent sides by definition. It has 4 right angles by definition. That's what makes it a combination of a rectangle and a rhombus. Diagonals are congruent, just like in a rectangle. Diagonals bisect opposite angles, just like in a rectangle. And diagonals are perpendicular, just like in a rhombus. And that was a rhombus too. I just misspoke. All right, so let's go look at this example, and then we'll do some simpler ones in a sec. All right, BCDE is a square. We're going to find the missing measurements. CE, any ideas? Diagonals bisect each other, so if this is 8, that has to be 8. So CE is 8. Oops, I'm just kidding. CE is 16. All right, BC, this side here, is kind of interesting. We want to know this piece. In a rectangle, I can't even talk. In a square, all the little pieces of the diagonals are congruent to each other. So we can fill in 8s, and now we have this right triangle right here to look at. We know that it's a right triangle because in a square, diagonals are perpendicular. And we really have this little guy right here, and we need to do the Pythagorean theorem again. So a squared plus b squared equals c squared. We don't know the hypotenuse this time, but we know both of the other ones. The legs are 8. And you know how to do this. All right, so C is 11.3, or that side. Which really means all of these are, by the way, because it's a square. All right, angle CFD right here is 90 degrees because in a square, diagonals are perpendicular. And angle DBE right here. Well, this whole angle is 90 degrees because it's a square. In a rhombus and a square, diagonals bisect the angles, which would be 90 divided by 2, 45 degrees. All right, so that's the end of the direct notes part. I'm going to show you how to do the examples on the back of your paper now. I'm going to stop this one and start a new one.